Here's problem 2516. Particle A, mass m, charge q, and B, mass m, charge 5q, are released from rest with the distance between them equal to 1 meter. If q is equal to 12 microcoulombs, what is the kinetic energy of particle B at the instant when the particles are 3 meters apart? Let's visualize what we have here. We have particle 1. Let's say this is mass 1 of mass m and charge 1 equal to big Q. And then we have another particle, also positive charge. This is mass 2 equal to m and charge equal to 5Q, 5 big Q. And they're located 1 meter apart, at least to begin with. The result of these two positive charges are going to be equal and opposite forces. So we're going to have a force this way and a force this way, equal and opposite. Sounds good. Sometime later, they're moving, and they've moved further apart. Same charges, but now they're 3 meters apart. And the question is, what's the kinetic energy of particle B? So we have particle A here, particle B here. Here's A, here's B. What's the kinetic energy of particle B? Well, normally in previous problems, what we did was we had a fixed charge, and then we found the potential difference as the other charge moved from one potential to another one with respect to the fixed charge. Here, the charges are not fixed. They're moving simultaneously. And so this kind of problem is better served by using the potential energy of the two-charge system, either initially and finally, and then finding that difference to determine the kinetic energy. So let's start with that. We know in general that the potential energy of a two-charge system is K, Q1, Q2, over the distance between them. And in this case, that means our initial potential energy is going to be K, Q1, Q2, over our initial separation distance. This is going to be 9 times 10 to the 9 times charge 1, which is 12 microcoulombs, 12 times 10 to the minus 6, times charge 2, which is 5Q, so that's going to be 5 times 12 times 10 to the minus 6, all over the distance between them, which is 1. So this is going to be 9 times 12 times 5 times 12. 10 to the 9 times 10 to the minus 12 will be 10 to the minus 3 over 1. So that's going to be what? 9 times 12 times 5 times 12. 6.48 joules. So that's our initial potential energy. Our final potential energy is going to be K, Q1, Q2, over our final distance, R2. And our K, Q1, Q2 is all the same. So we're going to have 6.48 joules, or 6.48 over 3 meters. So this is going to be 2.16 joules. So that'll be our final potential energy. So our change in potential energy, which is our final minus our initial, is going to be 2.16 minus 6.48, and that's going to be a negative 4.32 joules. All right, nice to know. I've always wanted to know that. We know that the change in kinetic energy plus the change in potential energy should equal 0. So our change in kinetic energy is going to equal the negative change in potential energy, and that's going to be equal to a positive 4.32 joules. So that is going to be the kinetic energy of the whole system, the change in kinetic energy of the whole system as we go from our initial to our final. But what does this mean for the kinetic energy of particle B? Well, we know that the masses of both particles were the same. Mass 1 is mass m, mass 2 is also m. And we know that kinetic energy goes as 1/2 mv squared, and we know that momentum goes as mass times velocity. Now, if these two particles have the same force magnitude on them, equal and opposite, then they will have the same change in momentum. In other words, force is equal to change in momentum over change in time. They'll be in part the same change in momentum because the total momentum should be constant, and our initial momentum was 0. So we should have the same magnitude momentum going in opposite directions, which means, given that they have the same mass, that they'll have the same magnitude of velocity. And if they have the same mass and the same magnitude of velocity, then these two particles will end up with the same magnitude of kinetic energy. So our total kinetic energy, which we had as 4.32 joules, will be shared between these two particles. So the kinetic energy of mass 2, or particle B if we will, is going to be 1/2 the total kinetic energy. And that's going to be 4.32 joules divided by 2, or 2.16 joules. So the kinetic energy of particle B is 2.16 joules.